Element 61. Sub and supercritical fluids.
All right, let's talk about sub and supercritical fluids. Now, you are all certainly aware of the most common three states of matter. That means materials can either be a solid, they can be a liquid, or they can be a gas. But some materials, when heated above a certain temperature and pressurized beyond a certain point, become what's called supercritical. They're not really a fluid, they're not really a gas anymore, but they're a supercritical fluid. Now, while these fluids have been known for centuries, recent discoveries have renewed interest in their excellent solvent properties. Carbon dioxide, both in a sub and a supercritical state, has been demonstrated at large scales as a practical solvent for everything from synthesis to extraction, cleaning, and analysis. One process you may be familiar with is extracting caffeine from coffee to make caffeine-free coffee, and that's often done with supercritical CO2. Now, the specific advantage, for example, of supercritical CO2 is that once you're done with the extraction, you can decompress the system, the CO2 turns into a gas, and if your product is, for example, a liquid, you don't have to specifically put any energy into separating the solvent from your product. Or so to say, the solvent simply evaporates. Now, the green advantages of supercritical fluids are numerous, including low toxicity for water and carbon dioxide, for example, but also the lack of flammability, their specific tunability, and the possibility of infinite recyclability by simply cycling pressure. Now, the use of carbon dioxide as a solvent does not require the generation of new CO2 and does not necessarily contribute to greenhouse gas emissions.